Here in Portugal, from the cliffs of Sagres, facing the howling swell of the ocean, they were dreaming of new worlds. In order to fulfill their thirst for discovery and conquest, they relied on their companions and partners, then on their ability to imagine and shape new systems. They started to build vessels, and from Sagres, this headland of the old continent, following Don Enrique, Henry the Navigator, they sailed to new lands, new horizons, new ambitions. Their next challenge was to throw bridges over the seas. They were discoverers. Today, we are the conquerors of the future. With windmill blades made of extra-light reinforced fabrics, we conquer the wind. With diesel particle filters, we conquer purity. With specific new crystals, we conquer the light. And the list of innovations goes on. Welcome to our fabulous adventure.
The name of the fabric is called the Dream Fabric.
We knew the result that we wanted to achieve, the collective results between us and the customer, but we didn't know exactly how to get there.
The aim is to make wind energy more competitive.
Getting countries to believe, getting investors to believe. It's a worldwide effort to get the acceptance for wind energy in general.
First thing was to develop a glass with higher stiffness, which Vetrotec's made. It's the H glass.
So we needed to find a fabric who is capable of following the curve of the blade.
So that's why we have to develop a completely new machine that would produce a stitch fabric where you could still move the glass in the layer.
It's not an R&D activity that we then have to convince someone of. It is an experience that we can expand upon.
It's Vetrotec's research who did really the development of the glass.
The glass itself has been made in Dudian in China.
We're talking about 30,000 tons of glass.
The fabric itself will be shipped to Spain and to Denmark.
So it's a really big amount of people working all together to have this one goal.
You know, we've been doubling our business every couple of years.
Developing a new glass is really a huge task, which as a small player you cannot do.
Saint-Gobain has truly become the leader in the wind industry.
We already have 50-meter blades. They're talking about 75-meter blades. There are people talking about 100-meter blades.
4 years ago, a blade of 61 meter was beyond imagination.
We know this works, and thank goodness we have the resources and experience within Saint-Gobain to make it happen faster.
Diesel was a problem in terms of pollution.
The project really started by building an R&D team 6 years ago.
Today, R&D is teamwork.
Well, the goal is to treat the emission from diesel cars, to remove all the carbonate particles.
It's a piece of ceramic shaped as a honeycomb with little cells and walls, and it's made out of porous silicon carbide. The filter is a way to hold the suit and also to withstand the high temperature which are generated by the suit burning, which can go up to 1200 degrees centigrade.
The elements of the filter are assembled together to make a big filters. The way we do that, which is crucial to the property of the product, is completely different from what our competitor would do.
And here in Rodental, our goal is to produce with 2 production lines, 500,000 filters per year.
We've chosen the first selection to be in Germany, the second one to be in Poland. We have a very multi-international team, French, German, Polish, and the challenge is to put a package together in a short time on a highly technical product delivered into an auto industry in high volumes.
To take such a risk by launching or industrializing such product, I think it's the first time that Saint-Gobain do that.
We are the first manufacturer in the world for silicon carbide, and we are able to extend our capacity to meet the target in terms of growth for the diesel particle filter.
All the project, since the first day started, was a long and difficult fight against time. We got an innovation team that is really working on the future project, and we got a development team that is talking to customer and adapting the product to their needs.
There is another big issue in the emissions, which is the nitrogen oxides, and maybe the second generation of filter will remove that.
Virtually all new cars will be equipped in 5 years from now.
The story of brilliance emerged a couple of years ago. We were doing some research with Delft University and looking at new materials, new compositions, and we were looking for something better than sodium iodide.
This new crystal from Saint-Gobain is really what we're looking for this time-of-flight product.
The brilliance crystal was really a revolution in our industry because of how fast the light was produced and how much light was produced compared to today's standards.
Well, this is a huge revolution. It's kind of a holy grail. It's something that the industry has been striving for many years.
First, we had to learn how to grow it.
We had some of this technology from before, it just had to be taken one step further.
We had the challenge of these crystals are hygroscopic, so when water or humidity attacks a crystal, it melts.
We had to build what I consider to be the best dry room in the world.
Only a few grams were produced by the university, so the question for us is, knowing that we can make a few grams, and a few grams are very, very good, how do we turn this into an industrial product line?
Our technical director, Mike Mayhew, said, that's it. That's the crystal that could be used for time-of-flight medical imaging.
Main use for us is to detect X-rays and gamma rays for a host of applications in nuclear medicine, mostly, security applications, for the oil industry, for instrumentations, and sometimes for space and physics applications.
One of the most exciting human benefits is in the detection of cancer. Pretty much been a balance. We've invested heavily internally to develop this crystal, but we also are investing quite a bit in working with our customers to co-develop new systems with this technology.
At Philips, we're extremely excited about the collaboration with Saint-Gobain. We think that we're going to make truly a huge impact in the marketplace.
We had a lot of credibility riding on this. You know, we told them that we could do this, and we did it. We did it on time, and we exceeded expectations. So for me, it's been a great project.
Just what the machine will be able to do will be very exciting and will be something that they've never seen before.
The last new crystal really to come out was back in the 70s.
In fact, there was one person that's worked here for over 35 years who was ready to retire, and he decided to delay retirement because he wanted to see this crystal. He said it was the first time he had seen a crystal so revolutionary in our industry. Our success started to happen with this new crystal.
Be it in the fields of crystals, ceramics, plastics, grains and powders, abrasives and reinforcements, we like to pursue our innovative quest. We invent for the benefit of all and in a more nature-friendly way, enriching our experiences from others. Exchanging, collaborating, and sharing with the various organizations in our sector. Gaining new markets, inventing new products to meet customers' demands. This is Saint-Gobain High-Performance Materials' spirit of conquest today. A spirit that still drives us to explore new continents and opportunities.